Welcome to our exploration of the maximum score from removing substrings problem from Leetcode. This problem, number 1717 on Leetcode, is all about removing specific substrings from a string to maximize your score. We'll break it down and make it easy to understand. Let's break down the problem and understand what we're dealing with. You are given a string s and two integers x and y. You can perform two types of operations any number of times: remove substring ab and gain x points, or remove substring ba and gain y points. Now, let's look at some examples to better understand how this works. In our first example, we have the string baobab with x equals 4 and y equals 5. Step by step, we remove ba first since y is greater than x. This gives us 5 points, making the string baobab. Then we remove ab, giving us 4 more points. We repeat this process until no ab or ba is left. The total score is 19. In our second example, we have the string ababxibab with x equals 5 and y equals 4. In this example, we consistently remove ab because x is greater than y. We follow this strategy to get the maximum points. We remove ab 4 times, each time earning 5 points. The total score here is 20. Let's summarize what we've learned about this problem. This problem involves greedily removing specific substrings to maximize your score. By prioritizing the higher point operation, you can achieve the maximum score. Understanding how to handle the removal efficiently is key. Once you grasp the concept, it's straightforward. We'll go through several examples to understand how this algorithm works. Let's start with our first example, with x equal to 4 and y equal to 5. The output of our algorithm for this input is 18. Let's go through the steps of how we arrived at this result. Remove ba from ababab, now s equals abab and 5 points area dead to thesker. Remove ba from abab, now s equals ab and 5 points area dead to thesker. Remove ab from ab, now s equals ab and 4 points area dead to thesker. Remove ab from ab, now s equals and 4 points area dead to thesker. Let's sum up the points we've earned. Total score equals 5 plus 5 plus 4 plus 4 is equal to 18. So, the maximum score we can achieve is 18. Our input string look at a slightly more complex example equal to 4 and y equal to 5. The output of our algorithm for this input is 19. Let's go through the steps of how we arrived at this result. Remove ba from baobab, now s equals bababab and 5 points area dead to thesker. Remove ba from bababab, now s equals kabab and 5 points area dead to thesker. Remove ba from kabab, now s equals cab and 5 points area dead to thesker. Remove ab from cab, now s equals cdbc and 4 points area dead to thesker. Let's sum up the points we've earned. Total score equals 5 plus 5 plus 5 plus 4 is equal to 19. So, the maximum score we can achieve is 19. For our final example, we'll see a case where the x and y values are equal to 4. The output of our algorithm for this input is 20. Let's go through the steps of how we arrived at this result. Remove ab from ababxibab, now s equals abaxibabab and 5 points area dead to thesker. Remove ab from abaxibabab, now s equals axibabab and 5 points area dead to thesker. Remove ab from axibabab, now s equals axibab and 5 points area dead to thesker. Remove ab from axibab, now s equals axib and 5 points area dead to thesker. Let's sum up the points we've earned. Total score equals 4 plus 4 plus 4 plus 4 is equal to 20. So, the maximum score we can achieve is 20. This concludes our explanation of the maximum score from removing substrings algorithm. Thank you for watching. This is the explanation of the maximum score from removing substrings. We'll go through the problem statement and solution approach. Let's begin. Given a string s and two integers x and y, earn x points for removing a b, earn y points for removing ba, can only remove non-overlapping sequences. Find the maximum points that can be earned. Solution approach. 1. Use a greedy approach. 2. Prioritize the higher value operation. 3. Use a stack for efficient removal. 4. Handle the remaining substring. Now, let's examine the Java code that implements this solution. We'll go through each important part of the code. The maximum gain method implements the main logic. It decides which operation to prioritize based on the point values. The calculate points method processes the string, removing pairs, and calculating the score. The remove processed method is similar to calculate points, but it only removes pairs without calculating the score. Let's analyze the time and space complexity of our solution. The time complexity is O, n, where n is the length of the string. We process each character in the string at most twice. The space complexity is also O, n. In the worst case, we might need to store the entire string in the string builder. This concludes our explanation of the maximum gain problem. The solution efficiently processes the string using a greedy approach, prioritizing the higher value operation. Thank you for watching.